Right, okay. Good morning, children. So, this session I am mainly focusing for the 2025 GC Advanced Level students who are going to take the exam in the coming few months. Okay, so many of the students are struggling with chemistry. So, chemistry is a very hard subject to fail because you can score marks, you can gather marks in chemistry, right? So, this is mainly for the students who are looking to take an S, right? They can go for a B, even they can go for an A. They have 4 months left. Okay, so this will be a series of sessions, I hope so. So first we'll start with inorganic, right? Inorganic structured essay questions. So basically what we are doing here is I'll be providing the important notes, right? Important notes I'll be teaching you all and providing it, and using those notes we will do the questions. So you will identify that there is the same pattern in each and every year, right? So if you figure out that, then it will be easy to score marks, right? So today we'll start with inorganic part. So first thing I'm gonna discuss is about the precipitates, right? So there are many precipitates form, yellow color, white color. So we'll be discussing those and we'll be doing the questions using the note. So you will figure out how the note is very effective for y'all. Okay, so that's the main focus of this session. For students who are mainly targeting for a S, they can go for a C, right? So if you follow the sessions, you'll go for a C, right? C, B, it's up to the talent of the student. So work with me, go with the notes, right? Note it down in your books and do the past papers. I'll be doing few here, right? You can do others at home, right? So it's your responsibility to do the past papers along with the notes. Okay, so right, we'll start without getting late, right? First of all, we'll go with some important man in our inorganic chemistry part, barium, right? Barium 2 plus. We'll be starting with that guy, right? Barium 2 plus. When you consider barium 2 plus, how will you find out barium 2 plus in the lab? Normally in the lab, if you go and ask for barium 2 plus, right, there will be no barium there. That means barium 2 plus is not available. It's in other forms. Normally barium 2 plus is a cation, right? So cation will always bind with a negative ion. Mostly it will be chloride ion, or it can be nitride ion, and it will be present as a compound in the lab, right? So here I am putting barium 2 plus, right? So normally barium 2 plus is available as barium chloride, or it can be available as barium nitride, right? So it can be this form. If you see this, you can see barium 2 plus is embedded here, right? So you can add barium 2 plus with by the addition of many compounds. You can add barium 2 plus to a solution. So end of the day, if you add barium 2 plus, we'll find out what are the precipitates that is possible, right? So first of all, the most famous one, when you add barium 2 plus, right, when you add barium 2 plus to sulfate ion, SO4 2 minus ion, when you add barium 2 plus to SO4 2 minus ion, the famous precipitate everyone knows, you'll get barium sulfate, right, which is a white precipitate. Barium sulfate, which is a, so I'll be marking precipitate as an arrow. So this arrow denotes it's a precipitate, right? Generally the downward arrow shows a precipitate, and if we draw upward arrow, that shows the gas is released. Okay, so here barium sulfate is a white precipitate, so I'll include the color also. It's a white precipitate, right? Now if you add dil HCl to barium sulfide, what happens? When you add dil HCl to barium sulfate, dilute HCl, you can see that there is no change to the barium sulfate precipitate, right? There will be no change, which means the sulfate doesn't dissolve, right? So this is the most general statement they give in the questions. When you do the questions, you will find out the pattern, right? So this is very important. But when you add barium 2 plus, mostly it is added in the form of barium chloride or barium nitrate, mostly barium chloride. So when you add it to a solution containing sulfate, you will get a white precipitate, right? And when you add dil HCl to that precipitate, there will be no change to the precipitate, which means the precipitate does not dissolve when dil HCl is added. Okay. And next one, what happens when you add barium 2 plus, right? When you add barium 2 plus to a solution containing SO3 2 minus, right? What happens when you add barium 2 plus to a solution containing SO3 2 minus, right? Again a white precipitate is formed, right? Again a white precipitate is formed. So you all can identify the formula BaSO3, right, which is a white precipitate, right? I'll mark the color also white, right? So what happens when you add dil HCl to BaSO3? What happens when you add dil HCl? You will see the precipitate dissolves, barium sulfate dissolves. Also there will be a gas released, right? There will be a gas released, that is SO2 gas, right? SO2 gas will be released. SO2 gas will be released while the precipitate dissolves. So this is the observation you will see when BaSO3, when barium sulfide is added to dil HCl solution, right? And next thing is the most a little bit common fellow, thiosulfate ion. When you add barium 2 plus to thiosulfate, BaS2O3 2 minus, right? Sorry, S2O3 2 minus. Okay. So again you will see a white precipitate. Again a white precipitate. Okay. So that is BaS2O3, which is a white precipitate, right? So what happens when you add dil HCl? When you add dil HCl to BaS2O3, what happens? Again the same fellow releases, right? Sulfur dioxide gas releases again. And other than that, there is another observation, right? So first of all, SO2 gas releases, right? SO2 gas releases. Apart from that, you will be able to see a turbid color in the solution. What is that turbid color? That is sulfur, right? Turbid, right? You can see sulfur forming. So what is turbid color? It's like a milky color. The solution turns into a milky color or pale yellow color. So when sulfur forms, the solution turns into a pale yellow color. So apart from that, something out of the box we have, that is carbonate, right? When you add carbonate to barium 2 plus, so generally this is not asked, but we have if you all have studied S block, right, it's not very important. CO3 2 minus is the carbonate ion, so you get a white precipitate again, barium carbonate, right? This is also another white precipitate that is possible to form by barium 2 plus, right? This is also white precipitate. And when you add dil HCl, what happens? When you add dil HCl to barium carbonate, barium carbonate, which is a white precipitate, right? Which is a white precipitate. So when you add dil HCl to barium carbonate, what happens is a gas evolves, which is a colorless, odorless gas, that is CO2. You can see CO2 evolving when when dil HCl is added to barium carbonate. So these are the main precipitates formed by barium 2 plus ion, right? And so this is the story of barium 2 plus, right? Barium 2 plus is mainly added in the form of I'll note it down here, barium chloride, or you can be added in the form of barium nitrate. So any form you can add, right? These are the common forms. Mostly barium 2 plus is added to the solution as barium chloride, right? So most common is barium chloride, right? So this is the note for barium 2 plus ion. So next we'll be going to the another famous fellow, that is silver plus, right? Silver plus, Ag plus, right? Right, Ag plus. Ag plus is a very quite big note, right? We'll draw in the middle, Ag plus, silver plus. So this is commonly added to the solution in the form of silver nitrate, AgNO3, right? Commonly added in the form of AgNO3 to the solution, right? So first we'll see what happens when Ag2 plus is added to these ions. Okay, first we'll go with that, right? When Ag plus is added to thiosulfate ion, what happens? S2O3 2 minus ion. What happens? White precipitate forms. What is the white precipitate? Ag, I'll write in red. Ag2S2O3, which is a white precipitate, right? Again a white precipitate. So you have lots of white precipitate here, right? A white precipitate, right? So but this doesn't stay as a white precipitate for a long time. It quickly converts to a black solid, right? It quickly converts to a black solid. Remember the keyword quickly, right? It quickly turns to a black solid. So I'll write that. So this fellow turns quickly. So the moment this Ag2S2O3 is formed, the moment this Ag2S2O3 is formed, it turns quickly to a black solid, right? Turns quickly to a black solid, right? What is that black solid? Ag2S, right? I'll go with Ag2S, silver sulfide, okay, which is a black solid. I'll mention the color. It's a black solid, right? So this is most famously asked part, turns quickly, right? Remember the word turns quickly, because we have another white precipitate which turns to black solid upon heating. So we'll discuss that next. So remember, turn quickly, right? Right. Now what happens when Ag plus is added to sulfide ion, right? What happens when Ag plus is added to sulfide ion, right? Sulfide ion is 2 minus. What happens is, again you get the black solid Ag2S, right, which is a black solid, right? Next we have SO3 2 minus and SO4 2 minus. So when you add SO3 2 minus to a solution containing silver plus, right, when you add SO3 2 minus, you will get what is the product formed? Yeah, Ag2SO3 is the product form, which is a white unstable precipitate, right? It is white unstable, right? This is white unstable. And same thing happens when SO4 2 minus sulfate ion is added to Ag plus, right? When SO4 2 minus is added, same thing happens. Ag2SO4, which is a white unstable precipitate forms, right? This is also white unstable precipitate, right? So those are the stories of Ag plus with sulfur containing ions, right? We spoke about S2O3 2 minus, S2 minus, SO3 2 minus and SO4 2 minus. Next we have Ag plus with halides, right? In our syllabus we have halides. What are halides? Those are group 17 elements. So mainly we talk about chloride, bromide and iodide, right? Cl minus, Br minus and I minus, right? So what happens when Ag plus is added with Cl minus ion, right? When you add silver plus iron to Cl minus chloride ion, you will get a famous white precipitate which is AgCl. Very famous, right? There is no paper without AgCl, right? Every paper contains silver chloride, either the MCQs or any part. AgCl is present, it's always present, right? So AgCl, very important. If possible, highlight 2 times, right? This is a white precipitate. This is a white precipitate, right? Next, this AgCl, what happens if you add dilute ammonia, right? When you add dilute ammonia, dilute or conc ammonia, right? How do I write? Right, I'll write like this. When you add ammonia, right, dilute or conc, right? When you add either of them, either when you add dilute ammonia or conc ammonia, AgCl dissolves, right? That's the idea you have to remember, dissolves. This fellow dissolve, right? Have no space, right? AgCl dissolves. So this is the main identification process to identify AgCl white precipitate is formed. And next one, what happens when you add bromide ion to Ag plus, right? When you add bromide, Br minus, what happens is again you get a not a white precipitate, it's a pale yellow precipitate, right? That fellow is AgBr. You get AgBr, right? Silver bromide, which is a very pale yellow precipitate, pale yellow. That's how the resource book says, so you have to stick with pale yellow, right? So when you add AgBr, you get a pale yellow precipitate. So this dissolves only when conc ammonia is added, right? Only with conc ammonia. Only conc ammonia. It dissolves, right? This fellow dissolves only when conc ammonia is added, right? Only when conc ammonia is added, this fellow dissolves, right? AgBr. If dilute ammonia is added, it won't dissolve, the precipitate remains. And finally, we speak about I minus ion. What happens when you add, so I don't have space here, right? Let me move this a bit. I'll create some space for me. Right, what happens now? I minus is added to the solution, right? Iodide ions. So I'll drag that fellow like this, okay? I minus, right? When you add A minus, again a precipitate is formed, but this time the precipitate from this time is AgI, silver iodide, which is a yellow precipitate, right? It is a yellow precipitate. This fellow doesn't dissolve in ammonia at all. It doesn't dissolve with ammonia at all. Even it's dilute, even it's strong, it doesn't dissolve, right? So I'll note it down. Conc or dil ammonia do not dissolve, right? Do not dissolve. Do not. So we have to underline that word. Do not dissolve, right? So right. So this is the story of silver plus iron with different anions. First we talk about sulfur containing anions, what happens when silver plus is added, and then we came to halides, what happens, right? So you can say AgCl is white, AgBr is pale yellow, AgI is yellow, and AgCl dissolves even with dilute or conc ammonia, AgBr dissolves only with conc ammonia, and silver iodide dissolves, it doesn't dissolve with either with conc or dil ammonia, right? So those are the main notes regarding silver plus iron. And next we'll talk about the next very important person in our syllabus, which is Pb2 plus, right? So it's better if I take a new slide, I think, right? I'll take a new slide, right? Pb2 plus, another important fellow in inorganic chemistry. Right, same thing we are talking, what happens when sulfate is added, sulfite is added, thiosulfate is added. We are talking the same thing with Pb2 plus, right? Right, then we'll quickly do this time, so you'll have done a practice, right? So Pb2 plus with SO4 2 minus ions, right? We are getting a sulfate PbSO4, right, which is a white precipitate. As usual, it's a white precipitate, right? As usual, it's a white precipitate, right? And this fellow, when you add dil HCl, to this fellow, same as in barium sulfate, no change, right? We will not see any change, the precipitate remains as same, right? No change is seen, right? Next, what happens when you add sulfite ion, SO3 2 minus ions, what happens? Same white precipitate forms, but this time, right, Pb SO3, same white precipitate forms, right? But this time when you add dil HCl to PbSO3, you will see SO2 gas releasing, right? SO2 gas releases, right? SO2 gas releases, right? Now what happens? The next sulfur containing fellow is 2O3 2 minus, right? Before that we'll go with sulfide ions, S2 minus, right? What happens when you add S2 minus? S2 minus, when you add, same as in silver plus, a black solid forms, PbS, right? PbS is formed, which is a black solid, right? A black solid. And next with thiosulfate. So what happens when you add thiosulfate? Right, it's 2O3 2 minus, right? Same story, a white precipitate forms as in silver, right? As in silver, it forms PbS2O3, which is a white precipitate, right? It is a white precipitate. And when you add dil HCl, sorry, so not dil HCl, sorry, okay. So upon heating this compound, right? Upon heating, what happens is you get PbS, which is a black solid. PbS, which is a black solid, right? PbS, which is a black solid. Same scenario you noticed with barium thiosulfate, right? Same thing, you got a white precipitate. When you add HCl, you got SO2 and sulfur, right? And when you go to thiosulfate, silver thiosulfate, you can see it turned quickly to Ag2S, right? You can see AgS2O3 turns quickly. I said to highlight this keyword to black color. But when you come to Pb2 plus containing, it turns upon heating. This triangle denotes when it heated only this white precipitate turns to black. But in the case of silver, it turns very quickly without heating. It turns to a black solid, right? The white precipitate eventually turns to a black solid. Then we have Pb2 plus with halides, right? We have Pb2 plus with halides. First one we'll talk about Cl minus. What happens when Cl minus is added? So you will see the PbCl2, which is a white precipitate, right? Which is a white precipitate. And this fellow PbCl2, very important, right? Very important. I'll write it here. PbCl2 dissolves by heating. When you heat it, it dissolves, right? Dissolve by heating and form needle. What is the word? Needle-like precipitates. Needle-like precipitates when recooled. So what happens is, I will take this part. When Pb lead chloride is heated, it dissolves, right? It dissolves, and when it is recooled, right? When you heat and when you recool it, it forms needle-like precipitates. The word needle-like is very important. Needle-like precipitates, okay? And next, when you add bromide ion to Pb2 plus, when you add bromide ions to Pb2 plus, Br minus, right? You get the precipitate PbBr2, right? PbBr2, which is a pale yellow precipitate, right? Pale yellow. Again, you can see the similarity, right? AgBr is pale yellow. AgBr is pale yellow. PbBr2 is pale yellow. PbCl2 is white. And AgCl is white, right? Silver iodide is yellow. Then you can find out what is the color of PbI2 also. It's also yellow. The same link, but some small changes, right? So it's easy to remember. So that's what I'm coming to tell here. It's easy to remember, right? So PbBr2, it's pale yellow color. So how to identify this fellow, right? PbBr2 dissolves by heating, right? Same thing, dissolves by heating. Dissolve by heating. But when recooled, it forms precipitate with no change. So the keyword is no change, right? No change. So again, PbBr2, if you heat it, it dissolves, and when you recool, it forms a precipitate with no change. But PbCl2, when it is recooled, right? I have missed the word recooled, I think. Dissolved by heating and recooled. And when recooled, form needle-like precipitate, right? Right, when recooled, it forms needle-like precipitate. So PbBr2, what happens is, when it is recooled, it it forms precipitate with no change, right? So PbBr2, it forms precipitate with no change, right? And final fellow, what happens with iodide? Let me take this a little bit upwards. Right. So next final one with iodide, what happens, right? This is for PbBr2. And finally with iodide, what happens? With I minus ion, it forms the precipitate PbI2, which is yellow. It forms a yellow precipitate, right? Yellow precipitate PbI2. And this fellow dissolved by heating, right? It dissolves by heating, and when recooled, it forms precipitate, right? It forms golden brown precipitate. So the keyword is golden brown, right? So here also we are talking Pb2 plus with sulfur containing ions, right? And then finally with halides, right? Those are the main fellows in inorganic chemistry, right? Apart from that, we have some small points. Gelatinous precipitate, right? You all might have come, if you all have done past papers, you all might have come across this word, gelatinous precipitate. So there are mainly two gelatinous precipitate in our syllabus. First fellow is aluminium hydroxide, right? Aluminium hydroxide is a gelatinous precipitate. And next fellow is zinc hydroxide. Right? Zinc hydroxide is another. So these are the two gelatinous precipitate in our syllabus, right? And next thing you all must know is about ammonia, right? Ammonia is a most commonly asked area. So there are three tests for ammonia, right? Mainly there are three tests for ammonia, right? What are those? First one is ammonia is the basic gas, right? This ammonia is the only basic gas in our syllabus. Remember that, only basic gas, right? There is no other basic gas in our syllabus other than ammonia, right? So first test to identify ammonia is it turns red litmus to blue. So you all might have studied in your oils also, right? Litmus papers. So when you take a red litmus fellow and when you put to ammonia containing, right, ammonia gas, when you keep near ammonia gas, that red litmus turns to blue color, right? So if that turns, then you can confirm that's ammonia gas. And second identification we have is ammonia gives ammonium chloride, right, which is a white fume. You get a white smoke, right, with conch. Let's take, when you are keeping conch HCl, right, you are keeping conch HCl near ammonia, then you will be able to see like white smokes forming, right? That is the ammonium chloride basically. So when white smoke is formed, you can confirm that ammonia is present, right? And third, then the final test to identify ammonia is brown color with Nessler's reagent, right? Ammonia basically gives brown color with Nessler's reagent, right? So who is this Nessler? What is he doing? Those are unnecessary, right? You have to know what ammonia gives brown color with Nessler's reagent. Nessler's reagent is basically a solution, right? And those are the main three identification tests for ammonia. So if you know this, you all can do a majority, like structured essay 2 questions you all can tackle, right? Because these are the commonly asked points, right? So I'll highlight some points. Those are the most commonly asked ones, right? Highlight barium sulfate BaSO4 when DiHCl is added, no change. This is a very highly tested area, right? And this you have to remember, when with the difference between BaSO3 and BaS2O3 is when you add DiHCl, barium thiosulfate provides a turbid solution, while barium sulfide does not produce a turbid solution, right? And again, silver sulfide AgCl is very highly tested, right? AgCl is very highly tested, and this point is also very highly tested, and these are not tested that much, right? Very rare. And these halides are also commonly tested, but mainly this is the more frequent, this and these are the most frequent. And when it comes to Pb2 plus, also same thing, PbCl2 is very commonly tested, and this point is very commonly tested, right? And that's also gelatinous precipitate in our syllabus is aluminum hydroxide and zinc hydroxide. You have to be aware of that. Okay, so using these notes we can do some questions. So let me do one question, right? And I will provide you the years. You have to do the other questions. All right. So the most basic 2016 I have taken, right? 2016 paper. So 2016 I have taken from 2016, right? So latest questions also the same thing is repeated, right? So I have given everything. So if you take the note, try to memorize it, or look at the note and do the questions, right? At one point you will get the pattern. So pattern is the very important part, right? So we'll start doing the question. Complete the reaction below by selecting the appropriate solution from the given list and write in the box, right? So first we'll start reading the observations, what happens, right? You can see a white precipitate that dissolves in HCl. So you can see barium chloride is present, and they are saying a white precipitate that dissolves in HCl. So almost all are white precipitates with barium 2 plus ion, right? So you have to go to the barium 2 plus ion, because you're adding a solution containing barium 2 plus. So you have to go to the note of barium 2 plus and you have to figure out what are the white precipitate that dissolves in DiHCl. So except barium sulfate, all others dissolve in DiHCl, right? Only barium sulfate doesn't dissolve. So this will keep it amate, right? Right. No, we can do this. So barium 2 plus is present, and they are saying a white precipitate. So what are the precipitates formed? I gave the note, right? Barium sulfate is a precipitate formed. Barium sulfite is a precipitate formed, right? Barium thiosulfate is a precipitate formed, right? And barium carbonate is a precipitate formed. That is the white precipitate that is formed with barium 2 plus. Now they are saying that dissolves in DiHCl. So you can basically cut barium sulfate, because barium sulfate doesn't dissolve in DiHCl. When you go through the note, you can see barium sulfate doesn't dissolve in DiHCl, right? So BaSO4 is straight away you can neglect it. and then you can see dissolves in DLHCl and gives a clear solution. All these fellows dissolve in DLHCl, yeah, that's true, but DLHCl to give a clear solution. This fellow gives a clear solution, this fellow gives a clear solution. But barium thiosulfate, does it give a clear solution? No. What's the reason? When DLHCl is added, it forms sulfur dioxide and sulfur, which is a turbid color solution. So here a turbid solution is formed, which is not a clear solution. So directly you can remove barium thiosulfate, right? So the remaining is barium sulfate and barium carbonate. Now when you go to the list, you can see thiosulfate is present, which is not a possible answer. Nitrate, so that is also not, we have nitrate definitely won't come, sulfate won't come. You have carbonate here, you have a carbonate containing ion, chloride, so we have carbonate containing ion. So it can be carbonate or it can be barium sulfate, right? So barium sulfate cannot be formed because the anion SO3 2-, right? SO3 2- is not present in this list, right? Because when you add barium, barium 2+ is coming from here, and the next anion should be coming from the other solution, right? So in this list you cannot see SO3 2-, right? But you can get barium carbonate because here there is carbonate, right? So this, when you add this carbonate to here, barium and ammonium carbonate can form this white precipitate. So here the answer is ammonium carbonate is the answer, right? NH42 CO3. And the precipitate A is, what is the precipitate A? Barium carbonate, right? Barium carbonate is the precipitate. Next you have to see lead nitrate. So lead nitrate, you have to, lead nitrate contains Pb2+, right? That's obvious. So now go to the Pb2+ note, right? And then you see the, you read the, try to read the observation, right? You can see yellow precipitate that dissolves in hot water. So when Pb2+ is added to something, you have only one yellow precipitate formed, right? One yellow precipitate formed. When you go to the note, you can see yellow precipitate, I have given only one, that is with I- ion, right? So I- ion is present. When you look at this list, you can see I- is present only in Ki. So obviously when Ki is added to lead nitrate only, you get this precipitate which dissolves in hot water. So I have given it dissolves upon heating, right? So hot water is also a heated one, right? So it definitely dissolves. So Ki is the B part. And what is the precipitate? PbI2, right? Very easy. When you go through the note, you can see Pb2+ forms only one yellow precipitate, and also that is with I-. So then you have a doubt, sir, Pb2+ forms precipitate with I-, right? Not Ki. So y'all are not O-level students, right? Ki contains I- ions, right? How Ki is formed? Basically Ki is formed by combination of K+ and I- ions, right? So that is a basic knowledge, right? So here definitely Ki is the answer, right? And third one, when silver nitrate, so silver nitrate contains Ag+, right? Silver nitrate contains Ag+. Now quickly go to the Ag+ note, right? Then you have say white precipitate that turns black on standing. So this is I highlighted, right? Black on standing, or what it turns black on standing, right? White precipitate that turns black on standing. This is a white precipitate. C is the white precipitate, not the black one, right? So silver plus forming white precipitate. What is the white precipitate which turns black? Silver thiosulfate, right? That is the only white precipitate which turns into black color, right? Right. Now what is the solution that you must have added here? What is the solution you must have added to nitrate? So you must have you have got silver thiosulfate. So silver comes from silver nitrate. So thiosulfate must be coming from the other solution, right? So only compound containing thiosulfate is sodium thiosulfate, right? So that is the answer. Very easy. So when you go through the note, it's very direct, right? So students struggle with these small things, right? They don't have the proper note either. Right, next you can see white precipitate that dissolves in HCl. So when you go to white precipitate that dissolve in HCl, there are a lot, right? When you go through the note, there are a lot. So it's a little bit difficult to find out. So we'll go further, right? We'll go further down the question and finally we'll try to figure this out. Right, next you can see with bromide ion, right? Bromide ion, you have pale yellow precipitate that dissolves completely in ammonia. When you read this statement, definitely you have to get. So pale yellow, it can be either PBBr2, right? Or it can be AgBr. Both are pale yellow, right? According to the note, only these two are pale yellow in color. Next they are saying they dissolve completely in conc ammonia. So I have spoken about ammonia only with AgBr, right? PBBr I have not given any note regarding ammonia, right? So I have said PBBr dissolves upon heating and when recooled it forms precipitate with no change. I have given AgBr dissolves in conc ammonia, right? So this directly tells the compound is AgBr, right? With no hesitation you have to write AgBr, right? Then to form AgBr, what is the compound that you must have added here? What is the compound you must have added here? Br comes from sodium bromide, so silver plus must come here. What is the silver containing compound they have given in the list? From the list you have to take silver containing compound, AgNO3. That is the only silver containing compound from the list, right? So AgNO3, very easy. And sixth one, when you go, you have added barium nitrate. So barium nitrate basically contains barium 2 plus. So go to the barium 2 plus note, right? There you can see white precipitate that does not dissolve in HCl. You have only white precipitate, it doesn't dissolve in HCl. I have given it, that is barium sulfate, right? You go to the barium 2 plus note and you figure this out. It's a direct one. So next you have to see what solution must be added here. You can see barium plus is coming from this solution, right? So again sulfate must be coming from here. The only sulfur containing compound is K2SO4. That is the only sulfate containing compound. So definitely this must be K2SO4, right? So you have written this, you have written this, you have written this, you have written this, you have written this. So only solution remaining is barium chloride and that must be coming here, right? If you are smart enough, you can take like that, right? Smart enough, but let me see. So here you have SO3 2 minus ion. Here you have barium 2 plus ion, right? What is the compound that is formed? BaSO3, right? Is it a white precipitate? Yes. Does it dissolve in HCl? Yes. And it dissolves and give SO2 also, right? So it's easy. All I have given in the note, right? All I have given in the note. So we have found out everything. So let me read the question for you all. Write the chemical formula of precipitates A to F. I have written everything, right? Write the balanced chemical equation for the dissolution of precipitates A, D, E and E. Alright. So let's quickly write barium carbonate. Barium carbonate, when you dissolve with HCl, I said CO2 gas is released, right? Basically this is all knowledge. Double displacement reaction. Barium combines with chlorine and H hydrogen combines with CO3, right? So barium combines with chlorine and forms, what does it form? Barium chloride. Simple, right? And this hydrogen and CO3 2 minus combine and form H2CO3, right? But this breaks down and forms CO2 and water, right? This will break down further and they form CO2 and water. So finally this CO2 and water only remains, right? So we can directly write it's CO2 and water, right? CO2 and water. That's basic knowledge. Definitely when you write chemical equations in inorganic chemistry you have to balance it, otherwise no marks. If you can't balance the equation, don't write the equation, right? Pointless. They won't give marks. If you don't balance it, they won't give, right? So I hope the equation no, 2. Now I think it's balanced, right? And next one, D BaSO3. BaSO3 with HCl, same barium chloride forms. Apart from that, you get SO3, SO2 and water, right? So I have given what are the gases formed, right? So only water and the next compound barium chloride is added, right? So soon try to balance it. I hope it's not balanced. 2HCl. I hope now it's balanced, right? So 3 2H, yeah. And finally E. What is the AgBr? AgBr with ammonia. So this is little bit out of a box. This is you have to learn from the past papers, right? So silver forms a complex, right? It forms a complex like this, and you will get 2 Br minus, right? You get a 1 Br minus. So this last one comes from paper practice, right? So even if you don't write this, you will lose only 2 marks, right? You will lose only 2 marks if you don't balance the final part. But others are easy, right? Others are direct questions, right? If you have revised the note properly, if you have studied the note properly, it's a very direct question, right? So students can get the answers very easily. So that's how it works, right? And that's it, you have done with the 2016 question, right? 2017 there are few small parts which I have not taught, but you can do it. But most commonly asked one is asked. So let's go for 2020 fellow. 2020, right? So again you can see, right? We'll do it quickly. The student is provided with bottles labeled PQRST and U containing aqueous solution of aluminum sulfate, H2SO4, and these are the, so they have given 6 test bottles, and 6 bottles contain these 6 solutions, right? We don't know what is the order, right? Some useful observations for the identification are given, right? So first go through the observation, right? A clear colorless solution, so definitely you can't find, there are a lot of clear colorless solution, right? So you can't get an idea reading that. A white precipitate, right? A white precipitate also, there are many white precipitates, right? A gelatinous white precipitate, right? So here we go with the hint, right? A gelatinous white precipitate. I said in our syllabus we have only 2 gelatinous precipitate. One is zinc hydroxide, another one is aluminum hydroxide, right? So when you go through the bottles, you can see aluminum is present, okay? And can you find zinc anywhere? No. So definitely this gelatinous precipitate is aluminum hydroxide. There is no doubt, right? So how can you get aluminum hydroxide? By mixing 2 solutions. One solution must be definitely an aluminum containing compound. The aluminum containing compound is Al2SO43. So definitely you must, one test tube must be aluminum sulfate, right? And what is the other fellow? Other fellow must have hydroxide ions, then only the gelatinous precipitate will be formed. So hydroxide ion containing compound is potassium hydroxide only. So definitely one test tube must be potassium hydroxide and one must be aluminum sulfate, right? Again you read the observation. Again a white precipitate. You have a plenty of white precipitates, right? Right. Next you read, a white precipitate turns black on heating. Turns black on heating. What is that white precipitate? On heating, yeah, Pb2S2O3, right? And on standing, that is different. On standing or when turns quickly is silver thiosulfate. This is on heating, right? so it definitely PbS2O3. So then the mixing of this solution must be, one solution must contain Pb2 plus ion and other solution must contain S2O3 2 minus ion, right? So when you look at it, the Pb2 plus ion contained solution is only this lead acetate, right? So definitely you must have added lead acetate, PbAc2, right? And the other fellow must be thiosulfate containing ion, which is only this possibility, sodium thiosulfate, right? And you read the final one, white precipitate dissolves on heating, right? What is the white precipitate that dissolves on heating? That is Pb, it can be I2O chloride, it can be PbI2, or it can be PbCl2, or it can be PbBr2, because all dissolve upon heating, right? So but definitely Pb must be present, so Pb is present only in Pb acetate, right? Definitely one solution must be Pb acetate. Out of these two, one must be Pb acetate, another must be either iodide containing compound or chloride containing compound or bromide containing compound, sorry, it must be PbBr2, right? So when you look at the list they have given, you can see only a chloride containing compound, so definitely this white precipitate must be, also they have said it's a white precipitate, right? So these lead bromide is a pale yellow precipitate, so definitely not this one. This lead iodide is yellow, so this white precipitate is PbCl2, right? PbCl2. So one solution must be lead acetate, it contains Pb2 plus ion, and next solution must contain chloride ion, which is barium chloride. When you mix barium chloride only, you can get PbCl2, right? Now what is the test tube P? You can see in the fifth also you need lead acetate, and in the sixth also you need lead acetate. So when you see here also you have used P 2 times, right? So definitely P must be what? Lead acetate, right? P must have lead acetate. That is from general knowledge you can see. Here also lead acetate used, here also you have used lead acetate, right? Here also you have used P test tube, here also you have used P bottle, right? So P bottle must have lead acetate solution, right? Then what must be Q? U must be barium chloride, right? U must be barium chloride. Then what must be Q? Q must be sodium thiosulfate, right? Q must be sodium thiosulfate, right? And right now you can see T and S, right? U and R, P and R, T and R. So R is commonly used everywhere, right? So how do you find out this, right? Right now you can see when you add U and R, so U is what is U? U is barium chloride, right? I'll write it here in red. This is for this part, right? When you add barium chloride to something, you get a white precipitate, right? So when you add barium chloride contain barium 2 plus ion. So barium 2 plus ion form precipitate with SO3 2 minus ions, SO4 2 minus ions, S2O3 2 minus ions, CO3 2 minus ions. So these are the white precipitates formed by barium 2 plus. So when you look at this list, you have SO4 2 minus, S2O3 2 minus, and that's it. You have sulfate and what you can see U, right? So we don't know U, right? But U cannot be aluminium sulfate. Why? Because gelatinous white precipitate is formed when aluminium sulfate is added. So either T or S must be aluminium sulfate. U cannot be aluminium because U is not used here. So U is not aluminium sulfate. You can remove that. So it can be H2SO4 And sodium thiosulfate also it cannot be, because we have Q is sodium thiosulfate, we found out. So H2SO4 must be what? R must be H2SO4, right? R must be H2SO4, because these are the only white precipitates that can be, when a barium 2 plus combines with these ions, these ions only you can get a white precipitate, right? So when you look at the solution, you have SO4 minus in two places, and you have thiosulfate. Thiosulfate you have found Q is thiosulfate, right? So R cannot be thiosulfate. Then Al2SO4 and H2SO4 are the options, but you know very well that in step 3 you need Al2SO4. So according to the bottle alphabet they have given, it can be either T or S, it cannot be U, because U is not used here. So U can be definitely H2SO4. The only remaining option is H2SO4, right? Like that you can find out. Then what is T and what is S? Right, before that, P and R. P is lead acetate, R is H2SO4, the white precipitate is PbSO4, right? That we have automatically found out. And T and R you get a colorless solution. R is H2SO4. Right. Now we'll see, when you add H2SO4 to Al2SO4, nothing happens, right? Nothing happens, because both contain sulfate ions, right? So this definitely T or S must be aluminum sulfate, right? One of them must be aluminum sulfate, one of them must be potassium hydroxide. So you can see when you add T to R, which is H2SO4, you get a clear colorless solution. When you add aluminum sulfate to R, you get a colorless solution, right? So probably T can be aluminum sulfate. Alright. So if T is aluminum sulfate, from this here you can see you have to use aluminum sulfate and potassium hydroxide. You have found out T is aluminum sulfate, then potassium hydroxide must be S, right? Potassium hydroxide must be S, right? But when you add T to R, like R is H2SO4, we have confirmed. Let's see other options also. When you add H2SO4, so R cannot be H2SO4, right? We have found out H2SO4 as R, right? So R is added to T, right? Sodium thiosulfate is Q, barium chloride is U, lead acetate is P, potassium hydroxide. What happens? What if you take T as potassium hydroxide? Then it's an acid base reaction, right? Because R is H2SO4. Then also you'll get a clear colorless solution. So T can be potassium hydroxide also. So either way, T can be potassium hydroxide also. If T is potassium hydroxide, you can take S as aluminum sulfate, right? You can take S as aluminum sulfate. So in this case, here both possibilities are possible, right? Because the observation suits both of them, right? So in the marking scheme also they have given, if you have written either of these, so they have given the marks. But what I suggest is you go with the observation. You read the observation and you find out where there is a famous observation. So white precipitate that turns black on heating. There are very few, only 2 observations, right? Where you can see it turns black on heating. You go with those. Find the one which you can find out the compounds easily, right? Go with the observation which you can find out the compound easily, and then you go to the, because when you start with a white precipitate, there are a lot, right? When you see the note, you will find out there are a lot of white precipitate. So start with the known observation. You see, gelatinous precipitate, you have only 2 in our syllabus. So start with those, right? And eventually you will find out the trend, right? So they have asked, given the balanced chemical equation. I hope that you all can just see the compounds and you all can figure it out, right? So try that by yourself, right? Definitely balancing is very important, otherwise don't write the equation, because definitely they won't give marks, right? For inorganic chemistry, balancing is important, and for physical chemistry, physical states are very important, otherwise no marks. That is for physical chemistry, right? And again you have the 2024 paper. This is also same thing. See, yellow precipitate, white precipitate soluble, right? White precipitate insoluble. So those are common terms. If you have done many questions, it's easy for you. So go through the note well and try the 2024 question, which is the last year question yesterday. So last year question, so probably 2025 might come in this trend, because 2020 was the last time came in a mixing way. So after that, after 4 years again the mixing way came in 2024, right? So 2025 I don't know if it was a mixed one. It's an advantage because easily you can find out, right? So go through the recording again, go through the notes, right? Keep the note with you and try to do the questions. Surely you will be able to succeed, right? Because getting marks in chemistry is very easy, right? It's very hard, very difficult to get fail the chemistry paper. So easy. Also inorganic, you all can score in organic. So organic mechanisms, if you study, you all can score. And small conversions, you all can get marks, right? So basically you all have to gather marks. Also you all can get the structured one, you all can get more than 90 marks, right? Because from the day you all start at A level, right? So you all are doing right those questions, so definitely you all can get. So structured essay you all can manage it, right? Essay also you all can do organic very well, and inorganic will do in the future, right? How to do 9A questions and how to do the 7B questions, D block elements. So you all have very few notes to remember. Some tutors they are giving books, right? Notes, so you all don't know which one to study, which one to leave. So here we'll be like taking the note shortly and we'll be doing questions, and we'll be see that you'll be able to see that the questions are directly related to the note, right? So I won't be doing 1 or 2 questions, I'll be doing 2-3 questions if time elapses, right? So in the future also I have a lot of plans, and those who are finding difficult and want to do more revision, you all can join my classes, right? So I'm doing online classes for the students, so you all can join. So if you all are interested to join, WhatsApp me to this number 0777 493632, right? 0777 493632. WhatsApp to this number and you all can join our classes, right? So all the best guys. So this is one session I have done for y'all, right? I have given the note, I have done the questions, and I have shown how to apply the note also. So go through it, and that's it for the day, right? So all the best guys, have a nice day, right?